Hi, I'm Ms. Hall, and this is lesson 43, Exponential Growth and Decay Functions, Exponent of NT. Let's start by reviewing the exponential growth model and the exponential decay model. This is from lesson 42. Exponential growth, the formula is y equals a times 1 plus r to the t, and decay is y equals a times 1 minus r, that minus sign nicer, minus r to the t. Okay, this is where a is equal to the initial amount. Let's do 1 plus r, 1 minus r, that binomial is equal to the growth or decay factor. R is equal to the percent change as a decimal. Percent change as a decimal. And t is equal to the number of time periods. Example 4, rewriting an exponential function. The amount y in grams of the Example 4, rewriting an exponential function. The amount y in grams of the radioactive isotope chromium-51 remaining after t days is y equals a times 0.5 to the t over 28th power, where a is the initial amount in grams. What percent of the chromium-51 decays each day? I'm going to rewrite the equation y equals a times 0.5 to the t over 28. What decays each day? So my goal is to get this equation in the exponential decay formula to look like this, where I want t to be the only exponent, not t over 28. I can rewrite the formula as 0.5 to the 1 over 28th, or the 28th root, all to the t power. I am using the power property of exponents, and then I can y equals a times, and 0.5 to the 1/28th, or the 28th root of 0.5, is approximately 0.9755. All to the t power. I'm so close to getting it in the right format. I can write this as y equals a times 1 minus some value. And I need to know what subtracted from 1 will get me 0.9755, and that is 0.0245. And now that it's here, I can answer the question. This is the percent decay, written as a decimal. So let me write it as a percent, because what percent of the chromium-51 decays each day? Where t is days, I need to make sure that t is days. It is 2.45% daily decay. Now we're going to look at compound interest. Consider an initial principal P deposited in an account that pays interest at an annual rate R expressed as a decimal. Compounded n times per year, the amount A in the account after t years is given by this formula. And in example 5, we're going to find the balance in an account using this compound interest formula. It says you deposit $9,000 in an account that pays 1.46% annual interest. Find the balance after 3 years when the interest is compounded quarterly. Okay, so we use this formula for compound interest problems. So So we want to know the amount after 3 years. The p-value, the principal amount, is the amount we started with, which is $9,000 in the account. 1 plus the annual rate, written as a decimal, so 0.0146, over n, the times per year. This is compounded quarterly, that means 4 times a year. And we're going to raise it to the n times t power, which is 4 times 3. So if it's compounded quarterly, that means it's compounded 4 times a year. So there are actually 12 pay periods for this account. And the amount after 3 years is going to be $9,402.21. In these compound interest problems, it makes sense to round everything to the nearest cent. So I wanted to give you one more problem where we're going to find the balance in this account after 3 years when the interest is compounded daily. So now instead of compounded quarterly, 4 times a year, compounded daily. And when it's compounded daily, you always use 365 as the number of days in the year. You don't worry about leap years. So we do still start with $9,000. The annual interest rate is the same, but now it's divided for every day, so 365. And the amount of pay periods, 365 times 3. And then you go ahead and put this in your calculator, and it's going to be interesting to note how much the account grows differently if you compound the interest quarterly or compound it daily. And the amount when it's compounded daily is $9,402.95. Okay, the August 2016 Algebra 2 Regents on exponential decay. We have the value of a car, and I want to get it in y equals a times 1 minus r to the t power form. And then look at these statements. So I'm going to take y, well, it's v there, it's fine. It's 32,000, which is the initial amount, times 0.81 to the 1/12th power all to the t. Because t is the number of months, so this is going to be number of months. And y equals 32,000, this is about 0.98259 to the t. 1 minus 0.017 to the t power. Okay, so which statement is not correct? So we have the car lost approximately 19% of its value each month. So now that I've got it in terms of months, it is not losing 19%, it's losing 1.7% of its value. So I know that that's incorrect, and I'm looking for one that's incorrect. So that seems like this is the one I'm going to circle, but let me keep going. The car maintained approximately 98% of its value each month. Sure, I just indicated that it was going down about 2% each month, which means another way of saying that, glass half full, is that it is maintained 98% of its value each month. So this one is correct. The value of the car when it was purchased was $32,000. Well, yeah, that's the A value, the initial amount. The value of the car 1 year after it was purchased was $25,920. And so what you want to put here is you need to remember that T is the number of months. To see if this is true, you need to substitute in a T value of 12. Right after 1 year. You could do it in the original equation. You just need to make sure that t equals 12, and you'll see that this one is true. So the correct answer, the statement that is not correct, is 1.